Hello again, Math 10Cs. In today's lesson, we're going to begin a new unit of study in the course, which is called Equations of Linear Relations. Although it's very much related to the previous short unit we did. So if anything, you can just think of it as an extension of the material we did in the previous unit on dealing with line segments and calculating slopes of those different line segments. Okay, so let's start off with this in this first warm-up. Now, it says the equations of the graphs of some relations are given. In each case, use a graphing calculator to sketch the graph of the relation. Make a rough sketch of the graph on the grid provided. Do not list any of the x or y intercepts. Well, just to save a little bit of time, I decided to do that for you. If you wanted to practice plugging these guys into your graphing calculator, you could go ahead and do it and see if you can get that graph so it look like these rough sketches here. But I simply just wanted to do it just so I could quickly illustrate the point in terms of identifying between what is a linear graph and what's a nonlinear graph. Okay, so we have 8 graphs here. We have this one, y equals 3x plus 1. Y equals negative 2x plus 3. And by the way, if you're plugging into your calculator, you could plug it into the y1. So you'd say like y1 equals 3x plus 1. And you just do the same thing for all the rest of them. Just plug in, delete, and then plug into y1 to get the remainder if you want to try that out. Okay, you have y equals negative 2x plus 3, y equals negative x cubed plus 1, y equals x squared minus 3, y equals 1 over x, y equals 1/2 x minus 2, y equals 4x, and y equals 2 to the power of x. Now, the question B says, of the graphs you see above, which ones are linear and which ones are nonlinear? So a linear graph means that it's a line, okay? So if you look at the graphs that I have here, the graphs that would be the linear ones would be this first one. So you have y equals 3x plus 1. You have the second graph, which is y equals negative 2x plus 3. You have the 6th and 7th graphs. So you have y equals 1/2 x minus 2. And then you have y is equal to 4x. Okay, those ones are all linear. The ones that are not linear have like that curvy type shape to it. So that would be graph 3, which is y equals negative x cubed plus 1. Sorry, that's a negative sign there. No, it's really small. You have the 4th graph. So that's y equals x squared minus 3. You have the 5th graph, y equals 1 over x. Or you could write this guy, because if you have like an inverse of like a variable, you could write that as y equals x to the negative 1. And we also have y equals 2 to the power of x. Now it says compare the lists. Write a rule from the equation which can be used to determine whether the graph is a straight line or not. Okay, this is what we want to focus on. Let's focus exclusively on the variable x. Okay, so here's my variable x, here's my variable x, here's my variable x, here's my variable x. Now, what I want to do is look at the exponents attached to all of these variables of x's. Now, for all of my straight line graphs, what do you notice is the connection between all the variables that have an x in it? Well, if it's a straight line, the variable x would have an exponent that's 1. So linear you'd have an exponent on the x, which is equal to 1. nonlinear, if you look at these exponents, this guy has an exponent 3, this one has an exponent 2, this one has an exponent of -1, not the same thing as +1. This guy here is weird because the variable in itself is actually in the exponent of the equation. So you would also need the x variable to not be in the exponent. So for nonlinear, we can say exponent on the x variable is not equal to 1. Or the exponent itself, or the x variable itself, is the exponent. Now for Math 10C, we're only going to worry about equations of graphs that are straight lines. So the linear equations is going to be exclusively our focus on this entire unit of study. Although we just wanted to quickly start off the unit by distinguishing between like how do you know if like an equation is linear compared to how do you know if an equation is nonlinear. So it turns out for an equation to be linear in math, it needs to fall in this form here. Y is equal to mx plus b. M and b can be like any real numbers. Like for example, you could have like y is equal to 3x plus 5. The value of m is 3, which is a real number. The value of b is 5, which is also a real number. So they're all going to fall into that format. And you can see it on the previous page here. They did all fall into that mx plus b format. Okay. So you have 3x plus 1, negative 2x plus 3. You had 1/2 x minus 2, and you had 4x. They all fall into that format. Okay, so let's start off by doing a little bit of an warm-up investigation to get to this this fact. Okay, so it says a person uses a graphing calculator to sketch the graph of the linear equation 2/3 x minus 1. I mean, yeah, we could use a graphing calculator to do that, but the big focus in this unit is going to be able to sketch these graphs without utilizing the graphing calculator. Okay, it says, use the sketch and points A and B to find the slope and the y-intercept of the graph 2/3 x minus 1. Okay, now, if you just flat out look at the graph here, you can see what the y-intercept is. The y-intercept is point B. Your y-intercept is where the line would actually hit the y-axis. So that would have coordinates of 0 and -1. Okay, so here I could say my y-intercept is equal to -1. Or if you want to write it down as an ordered pair, you could write down 0, -1. Now to get the slope, well, because I already have a graph, I think the easiest thing to do right now would just be to draw a slope triangle. So if I do a slope triangle, my run would be equal to 3, and my rise, because I'm going up and towards the right, would be 2. So if I calculate the slope, and again, we use the variable m to represent the slope. So we'd have m is equal to rise over run, which would be equal to, the rise is 2, and the run is 3. Okay, so for this line here, your y-intercept is -1, and your slope is 2/3, which just means for like every increase in height by 2, your graph would go across by 3 units. Okay, now it says, compare the values found in A with the coefficient of x and the constant term in this equation. Okay, so let's look at this. We have y equals 2/3 x minus 1. This value of the 2/3 here, since we calculated, the value of the coefficient attached to the x, that is the slope. This other value here, the -1, so that's like the constant term, that represents the y-intercept of the graph. Okay, so let's look at part C now. So C says they sketched the graphs of two more linear equations, used the grid to determine the slope and the y-intercept of these different graphs. Okay, so y equals 2x plus 1 is this graph. So it's easiest to see the y-intercept first. So the y-intercept right here would just be this point. So that point would be a y-intercept that is 0, comma, +1. So we could write down the y-intercept is equal to +1. And the slope of this graph, well, let's draw a slope triangle. Again, it doesn't matter where you draw a slope triangle, just try to make it so it starts and ends at grid line intersection points. So here, you'd have a run that is equal to 2, and you'd have a rise that's equal to 1, 2, 3, 4. Okay, so if you calculated the slope, then the slope of this guy would be slope is equal to m, which is rise over run, which would be equal to 4 divided by 2, which would be equal to 2. So the slope of this graph is equal to 2. Let's do the other one. Okay, so the y-intercept on this graph, so this graph is -5 over 2x minus 3. So your y-intercept on this graph is located right, oh, not here. It's where it hits the x-axis or the y-axis at. Okay, so here, that's my y-intercept. Okay, so your y-intercept on this graph would be 0, comma, -3. So we could label that here. We could say the y-intercept of this graph is equal to -3. Now the slope, well, let's draw a slope triangle. So let's see, let's start here, go across, and go all the way up. That looks terrible. Let's redraw that line. Okay, so it goes up to about right here. Okay, so the rise would be equal to, now careful here, because like from left to right, you actually go down by 1, 2, 3, 4, 5. So that'd be a rise of -5. And the run would be equal to, you go 2 across. Therefore, the slope of that line would be equal to m, which is the rise over the run, which would be equal to -5 over 2. Okay, so you got -5 over 2. And then it says here, make a conjecture about the slope and the y-intercept of the linear equation y is equal to mx plus b. Okay, well, we should be able to see this here. So if you look at the coefficient attached to x, the coefficient attached to x, so you got a 2 here, and you got a -5 over 2 here. That's what the m is, okay? In the equation y equals mx plus b, the m represents the slope of the line. And then if you look at the constant term, the constant terms, you got +1 here, and you got -3 there. The constant term actually represents the y-intercept. Now, we use a different variable to represent this. So we use the variable b to indicate what the y-intercept of the graph is. So if you have an equation in the form y equals mx plus b, the coefficient beside the x value tells you what the slope of the graph is, and the constant term on its own tells you what the value of the y-intercept is. Okay, so and we can see that here. Y equals 2x plus 1. The slope is 2. The y-intercept is 1. Y equals negative 5 over 2x minus 3. The slope is negative 5 over 2. The y-intercept is negative 3. If we go up here, you have 2 over 3x minus 1. So 2 over 3 is the slope. The negative 1 is the y-intercept. And if you went back to the first page, it'd be similar for all these different linear graphs as well. Like y equals 3x plus 1. The slope would be 3. The y-intercept would be 1. Y equals negative 2x plus 3. The slope would be negative 2. The y-intercept would be 1. Y equals 1/2 x minus 2. The slope would be 1/2. The y-intercept would be negative 2. In this one, you have y equals 4x, but so the slope would be 4, but there's no term adding there. It'd be the same thing as adding 0. So if you had like 4x plus 0, it'd be like you have a y-intercept of nothing. Okay, so slope would be 4, y-intercept would be nothing at all. Okay, and that's kind of what we said initially. We said a linear equation is in the form y equals mx plus b, but the key thing is that m is the slope, b is the y-intercept. Okay, let's go to the next page. Okay, so another student uses a graphing calculator to plot the linear relation 2y is equal to 5x plus 8. It says use the sketch to determine the slope and the y-intercept of 2y equals 5x plus 8. Okay, so I can see the y-intercept, it's right here. Okay, so your y-intercept would have coordinates of 0, 4. Now the slope, if we draw a slope triangle, so let's try to figure out where some endpoints are on the grid lines. So it looks like we can go between, actually it just conveniently labels the dots for me in the diagram. So if we drew a slope triangle, your run would be equal to 2, and your rise would be equal to 1, 2, 3, 4, 5. Okay, so your slope, which is m, would be equal to rise over run, which would be equal to the rise, which is 5, divided by the run, which is 2. So your slope is m is equal to 5 over 2. And your y-intercept, which is, we use the variable b to represent it. The y-intercept b has a value of 4. Now here's where it gets a bit weird, because it says, okay, I have a slope of 5 over 2, I have a y-intercept of 4, but the graph is 2y equals 5x plus 8. But wait a second, the coefficient attached to x is 5, not 5 over 2, and the constant term is 8, it's not 4. So there seems to be a little bit of a contradiction here. Now, here's where there's an issue. The problem with the way this equation here is written is it's not quite in the format y equals mx plus b. To be in the form y equals mx plus b, you cannot have any number in front of the y. The only coefficient that can be attached to the y is a 1. So I'll write that out here. So I'll say for the equation, the linear equation, y equals mx plus b, the numerical coefficient of y must be 1. Okay, it has to be 1. So the problem with this equation is you have that 2 in front of it. You have 2y is equal to 5x plus 8. Now, we can actually take this equation and we can turn it into the form y equals mx plus b. all we need to do is we need to isolate the variable y. So the way we would do that is we're going to divide this side of the equation by 2. I'll do it in a different color, actually. Okay, so we're going to divide this side of the equation by 2. And whenever you do one side, you have to do the other. And I'm also going to divide this side of the equation by 2. Okay, so these 2's are going to cancel off. And now you're going to be left with an equation that tells you y is equal to 5x plus 8 over 2. Now, we can actually combine these into two separate fractions. The way to combine it into two fractions is if you take this numerator and divide it by the denominator, that gives you the value of the first fraction, okay? So this would then be expanded to y is equal to 5x over 2. To get the second fraction, you can take this part of the numerator and divide by that same denominator. So this would then be plus 8 over 2. Now let's try to reduce a little bit. So this would then turn into y is equal to, well, 5 over 2 doesn't reduce, 5 over 2x plus 4. This is now in the proper format. So this is now in the format that's y is equal to mx plus b. Again, you cannot have anything in front of the y. If you have a number in front of the y, you need to get rid of it by dividing the equation, both sides of the equation by the number that's in front of that y. Now things actually match up. So if you look here, after I've been isolated for y, okay, well, now it's in y equals mx plus b. So what's the, let's change this to red. Okay, so what's the value of m? It's the value beside the x, which is 5 over 2. And that matches the slope I calculated from the graph. What's the value of the constant term? Well, that's the y-intercept, okay? Which is the same y-intercept we initially calculated. So as long as you take that equation and just isolate for y, get it into the form y equals mx plus b, then the coefficient beside the x is the slope, and the constant term would be the y-intercept. But you have to have that variable y isolated. Okay, so this just summarizes everything now. So it says the graph of an equation in the form y equals mx plus b, or if we want to write it in function notation, we're not going to worry too much about function notation in this unit. So function notation, instead of writing the output y, you can write down the output of f as a function of y. So you could write down y equals mx plus b, or f of x equals mx plus b is a straight line that has a slope of m and a y-intercept of b. The equation y equals mx plus b is what we refer to in mathematics as the slope y-intercept form of a linear equation, okay? Slope y-intercept form because it's written to tell you what the slope is, and it's also written to tell you what the y-intercept of the graph is. And it says you can use the graph of an equation to draw a graph of this line without making a table of values. And I'll show you what that looks like in the next example on the following page once we get to it. Okay, so a couple of examples here. So it says determine the slope and y-intercept of each one of these equations listed. Okay, so the thing you should first of all ask yourself is it in the form y equals mx plus b? Because if it is, it's really easy to identify what the slope and the y-intercept is going to be equal to. Okay, so this one right here, well, no problem. Okay, the y value is isolated, so this is in the format y equals mx plus b. So here, the number beside the x variable, that's your slope. So this would be m is equal to 3. And the constant term, that's your y-intercept. So that'd be b is equal to 2. For this one, just check, is it in the form y equals mx plus b? Yeah, it is. It's written a little bit differently. Like if you rewrite this guy as y is equal to negative 2 over 3x. Sorry, looks a little bit funky there. 2 over 3x plus 7. So all I did here is I just switched these two guys around, okay? So negative 2 over 3x plus 7. Yeah, now that's in the form y equals mx plus b. So in this equation, the slope is the number in front of the x, which would be a slope of negative 2 over 3. And the y-intercept would just be the constant term, and the constant term is a 7. How about this one? Is this guy in the form y equals mx plus b? Well, no, it isn't, because you have a 6 in front of the variable y. So I want to get it into that format, and I can do that by dividing both sides of the equation by the 6 here. So we'll divide by 6. We'll divide by 6. Okay, so that's going to get rid of the 6 on this side. So those cancel off. And then I would then have y is equal to 8x plus 1 over 6. And again, we want to write this as two separate fractions now. So the first fraction would be, you take this part of the numerator and divide by the denominator. So then that would give you 8x over 6. Oops. Eight x over 6. And then to get the second part of the fraction, you're going to take the other part of the numerator. So you take the positive 1 over 6. So this would be 8 over 6 plus 1 over 6. Now, you can reduce that fraction on the left-hand side there, because 8 over 6, if you divide both the top and bottom by 2, would turn into 4 over 3. And you'd have x plus 1 over 6. Okay, so now it's in the form y equals mx plus b. Okay, so now it's y equals mx plus b. Therefore, your slope here would be 4 over 3, and the y-intercept would have a value of 1 divided by 6. Okay, so that's the power of writing it in that format. Y equals mx plus b is a very easy way to identify what the slope and y-intercept of the graph is. Now, that's going to be useful to us because that's going to allow us to graph these equations quite easily. Okay, so this second example is going to get us to do that. So it says, consider the equation y equals 2x minus 5. State the slope and the y-intercept. Okay, so first of all, this is in the format y equals mx plus b. So your slope is the value of m, and the value of m is the number in front of the x. So that's going to be a slope of m is equal to 2. And then the y-intercept would be the constant term. So that's going to include the negative sign in front of it as well. So the value of b would be equal to negative 5. Okay, it says mark the y-intercept on the grid. So the y-intercept is going to be where the graph hits the y-intercept at. So that's going to be at this point right here. So that's going to be at negative 5. Now it says use the y-intercept and the formula slope equals rise over run to mark 3 other points on the grid, join the points together, and extend the line. Okay, here's how I would, so we're going to try to graph this by hand, and here's how I would do this, okay? So I'm going to write down a list of steps here to actually like plot this. So I'm going to say starting at the y-intercept, now in this case here, the y-intercept is the point 0, comma, negative 5. What I want to do is I want to plot a second point. So to plot a second point, so what I want to do to plot a second point is from the y-intercept, I'm going to go up or down by the rise. And then I'm going to go right. Again, the assumption is we're always going towards the right. Go right by the run. Okay, so here's how you would do this. Okay, so your slope, m, is equal to 2 here, and that's equal to rise over run. Okay, so let's just figure out what are some values you could plug in for rise or run that would give you a value that's equal to 2. Well, the simplest fraction you could plug in here to get a value of 2 is you could just write down 2 over 1. Okay, a rise of 2 divided by a run of 1 would be equal to 2. So I can say my rise is equal to positive 2, and my run is equal to 1. So here's what I'm going to do on the graph now. So I want to plot a second point, because if I have a second point, I can then draw a straight line. So on the graph, so let's go here. What I'm going to do is from the y-intercept, I'm going to go up by 2. Okay, so if I go up by 2, I go up by 2 here, and that's a rise that would be equal to positive 2. And then I'm going to go right by the run. So I'm going to go across just by 1. So what I'm doing here is I'm actually forming a slope triangle. I'm kind of doing it backwards though. So the run of 1. And then wherever this ends off at, so like you go up or down by the rise and then go across by the run, and wherever the part of the run ends off at, that's going to be where your second point is. So my second point is then going to be located right here. Okay, now what I can do is to construct a straight line, all you need to have is 2 points. So now that I have 2 points, I can actually make a line go through these points. So let's grab a line here. We'll make it blue in color. Oh, here's the line. Blue, and then, okay, let's make it a bit thicker. Okay, so I'm going to take this line, and then I'm going to put it through these 2 points. Okay, that's my straight line. And if I want to, I could go back now, and then I could put the arrows on them. Okay, so that's one way of constructing a line just by using the equation. So that's the power of the y equals mx plus b equation, is you can plot the graph really easily. So what you would do is start the y-intercept, which has a value of -5, and then use the slope to get another point. So a slope of 2 would tell you can go up by 2 and then across by 1. So if you go up 2 across 1, here's another point. So this point here would be 1. Oh, let's give the smart notebook a second. It doesn't seem to like what I'm doing. I should point out, by the way, that you don't have to make the slope triangle that smaller. Like there's lots of different fractions that could give you a slope of 2. Like you could go 8 divided by 4, in which case you go up by 8 and then across by 4. And you could also get another point there. Okay, so this point is 1, comma, I think it's -3. Because it wants to mark 3 other points on the grid. Okay, so that's another point. Let's see what else we got here. Really depends on how accurately I actually drew this thing. So I think it's supposed to hit the graph right here. So I mean, another point should technically be 2, comma, what is that? 2, comma, -1. Okay, I don't think I drew it as accurately as I could have. And another point down here, so this is mark a third point, would be, that's -1. I think we're down to -7 in that situation. Let's check here. So we've got this point, which is -1, -7. We've got this point, which is 1, -3. And we've got this point, which is 2, -1. Okay, and this point, 0, -5. Okay, so that's one way you can draw a graph from the equation y equals mx plus b. Okay, so it says consider the equation y equals 2/3 x minus 6. State the y-intercept. Well, right away, y equals mx plus b. So the y-intercept is the value of b. So you'd have b is equal to -6. Determine the x-intercept algebraically. Okay, so let's write down the equation. So y is equal to 2/3x minus 6. Let's rewrite that so it actually looks like a proper 6. Okay, now to get the x-intercept of a graph algebraically, the x-intercept is where your value of y is 0. Because if you're on the x-axis, where the graph intersects the x-axis, the value of y is 0 at that point. So I'll say your x-intercept is when y is equal to 0. Okay, so I'm going to plug in y equals 0 in the equation and solve for the value of x. So this would turn into 0 is equal to 2/3x minus 6. Okay, we got to get the x isolated. So first things first, we're going to get rid of this +6. So do the reverse order of operations. Deal with the addition and subtraction first when you isolate an equation. So we'll add 6, add 6. I can't write 6s evidently. Okay, so 6 would be equal to 2/3x. Okay, we want to solve for x, so we got to get rid of this 2/3 part. So first of all, let's just get the two x isolated. So the way I'm going to do that is I'm going to bring this 3 up to the other side. So if I do that, this would then turn into, sorry, I want to use a different color. I want to go back to blue again. Okay, so this would be 6 multiplied by 3 would then be equal to 2x. Okay, so this would then be 18 is equal to 2x. To solve for x, divide both sides of the equation by 2. Divide 2, the 2's cancel. And then you'd have your x-intercept is equal to 9. Okay, now it says mark the x and y intercepts on the grid and then join the points to form a straight line. Okay, well the y-intercept is -6, so that's down here. So that's at this location. The x-intercept has a value of +9, so +9 is going to be at this location. And again, to form a straight line, you just need 2 points. Okay, and I have the 2 points now. So let's try to see if I can get a line to go through here. Okay, might be able to do a better job than that if I actually like pull the ruler out by hand. And then we can just label the endpoints. Or not label, just draw the arrows for like the line to show it's continuous. And that's another way of getting the line. Okay, so I kind of showed you 2 methods. Like one method is like you can plot the y-intercept and then make a slope triangle to get the second point and then connect the dots. The other method is you can plot the y-intercept, then algebraically calculate the x-intercept, plot it, and then just connect those 2 dots and form a line. I should mention part D, even above, said verify using a graphing calculator. I'm not going to do that right now, okay? So you could use a graphing calculator to plot y1 equals, if you want to plot it, you'd be like y1 is equal to, I put the fraction in brackets, So like 2 over 3x, and then minus 6. And then to calculate the intercepts using the graphing calculator, so the y-intercept, you would use that function, you'd go second, then you'd hit trace. And then you'd select number 1, which says value. And then it'll tell you to input a value of x. The y-intercept is when x equals 0. The x-intercept, you basically start off by doing the same thing. So you go second, and then you go trace. Except this time you're going to pick the 0 function. So you pick 2, which I believe is 0. And then you have to set the left and right bounds about the x-intercept. So again, to do this in your graphing calculator, you have to adjust the window settings so you can see both the x and y-intercept. And then you can use these functions to calculate it. Okay, so that's it for this lesson, an introduction to the equation of what a straight line looks like. And you can do numbers 1 through 7. And I will talk to you in the next lesson.